and data modeling and question. Right. So yes, now we are in a situation like we understand that you could extract data and you have transformed data and now you have stored data in data mart. Now the situation is that the data is in data marts. So you decided to bring this data pertaining to the algorithms that you're planning to execute.
Yes.
How did you decide these algorithms and what sort of algorithms that you were looking at?
Yes, ma'am. So before now, if we go into MLs, so there is everyone knows that there are two types of algorithms. So
Yeah.
one is the supervised learning method
Yeah.
and unsupervised.
Yeah.
In the supervised learning method, we know that this is the exact outcome that we can feed in the data. The algorithm will differentiate the outcome. But in this case, we didn't know the exact anomaly part,
Yeah.
transaction. So we have made the data marts using the hypothesis that we had, the rule engine, and using the data source data fields, and we have cleansed it and we have made the data mart. We had to use the unsupervised learning method to identify what sort of anomalies that we can feature.
Okay.
For that, we need to get certain like features. Like we have to extract feature detection process to from this data set, what sort of features can be subject to these algorithms, unsupervised learning. So we use like k-means, linear regression, nearest neighbors, random forest. So there are number of algorithms available for unsupervised learning. So they will give different sets of results. They will cluster the data that we point out.
Okay.
So although we cannot say this is the correct algorithm, differentiate. Okay, use a A algorithm, and we cannot say this is the accurate one.
Okay.
You have to train the algorithm day in, day out. So that's why the volume is a matter and the data quality is a matter. So what the algorithm will do is it will identify certain relationship with the features that we give it.
Okay. So is it because of the complexities of the use cases that you cannot stick into a single algorithm?
It could be. I mean, it gives us the output like we use to measure the efficiency. So some of the algorithms might give us a 90. Normally, whatever the training that we do, we aim to have a higher efficiency output from the algorithm. So the features that we feed in, we can give a number of features, but we have to identify the correct features that we need to put into the algorithm. So example, retailers GPS location can be one.
Okay.
And the amount that has been and the network age the customer was in. I mean how many years was the customer was in, how many the wallet was created, how many days were there. So these were different features that we tested out using these algorithms.
Okay.
So once we train the algorithm, we identify a certain efficacy level.
Okay.
When we come to a certain efficiency level that we have surpassed, we go to the business itself. So before putting it to the production level, we go to the business end and we try to sit with them and understand whether this is a particular anomaly that you see.
Which in simple terms that we try to test it in a different all over environment and make sure that this is acceptable to
evaluation of the algorithm is a must because before putting it to the production, we may come as a third party, identify the scenario, build up the solution, but the business end user know the best result. So once we show them different outputs of these algorithms to them, they will give us a feedback. That's how.
Right. When you do this training process, right? So how did you fetch this data? So you have to connect to these data marts and then you have to run these algorithms on.
Right.
So how did you do that?
So the algorithms, the data marts were there. Initially, we had because we were having zero cost base, we had our own data source, data servers, databases there, Oracle databases. So then we connected the algorithms and we ran over a testing system directly featuring. But later on,
so it means you had the resource. So you had servers, some sort of hardware.
We had the data space was there for us to store. the the data marks, so that we could evaluate day in day out the algorithms. Later on, then when we upgraded our systems, we went to a private cloud as well.
Okay.
So private cloud, they gave us the more features. We use like tools like Snowflake. They will give us more features to train. So those kind of features were used, and we evaluated these algorithms, different sets of algorithms, by connecting the data direct manner, point of manner.
Okay.
And
I'll just interject there. So just to ensure for the viewer who is having a question as to this amount of data is personal data at the end of the day, monopolized data. So at that point, even at that point in time, Dialog was having, I think, Sri Lanka's most advanced personal data protection and information security management policy. And I think even the cloud architectures, we were having a personal cloud, the data mask, everything, internal audit and all of the divisions were working with the highest information security management standards available. I think at that point in time, I think PDP, GDPR, we actually had surpassed all the requirements as well.
Okay.
So with that, we ensure that there is 100% security to the data. There are 0% violations for any of the world-class information security or personal data protection standards as well.
You must have done some tracing also before.
Yes, plenty of tracing has been happening, and with that, at each and every strategy on how we are administering the data, we consulted our information security division.
Okay.
We consulted the data standard available. Even we don't take the word of the information security division. We, as internal audit, we do our second testing as well, and all the testing what we have done, we had another internal division to do the peer review testing to ensure that it's happening on the quality parameters were consecutively adhered to, so that there will be
data governance was there, and any unwanted confidential one, we masked the data. So if
The sensitive part of the
sensitive part of the data. So likewise, the training, the algorithms.
Okay. Right. So once you did the training, that you can get to know certain level of accuracy. And then how did you move to the actual scenarios, like to the production levels?
Yeah, so
You need to get some acceptance. Yes. So whether it is applicable, yes.
we went to the business, like I said, so when they thought this from output perspective, we want to give them how we could alert them.
Yeah.
So the visualization part came at that stage. So we used certain visualization. Tableau was one area that we used. So the desktop license was there. So we built these anomaly behaviors. We took them as flags, and we gave like a dashboard point of view how to trace back in this scenario the suspicious transaction as a flow, how we can trace back from its initiation point to its person.
So that was one of the practical points where internal audit started doing the marketing part. So because we were now classically from the, if you take a certain business line, the first level of defense, that is the basic control.
Yes.
For example, when you're registering a certain document, you need to have a signature of the person. That's first level of control.
Yeah.
Second level of control is the back office function when they are inputting the data. For an example, if let's say the identity card, you do a check to see from the first 4 digits whether the person is 18 years old.
Yeah.
So that's the second level of testing. Third level of testing is when you do the subsequent auditing, you find that this ID has been registered 6 times. So that's the third level of control, but you need to check. Now, for a business to progress ahead, ideally you should have a very strong first and second level testing, because the third level testing happens perhaps a good 3 to 4 months down the line after the transaction has occurred, and you have a possibility of a penalty. So now, actually, with this model, internal audit was now slowly getting into the second level of defense, where now the business has kind of ample notice before the specific, what do you call it, non-compliance occurred, or even at least I think we were looking at a model of training the system to have a T-1 minute. So that, let's say yesterday the transaction occurred, today you should be able to find out that the non-compliance occurred, so that you have ample time to go in, do the rectification and ensure that you comply to the specific rules. Well, this was an ideal opportunity where internal audit market itself to the function as a enabling. So I think that now fixes itself into the primary proposition I was telling you. To the corporate strategy, how internal audit fixes itself into the corporate strategy and ensuring that the ultimate corporate objectives are being achieved in an effective manner with the technical capability what internal audit has. What we need to identify is that the internal auditors in an organization is an ideal asset where these auditors have the exposure and view to almost all of the nooks and crannies of the organization. I mean, they've been working right throughout all the verticals, all the operational verticals of the organization.
Okay.
So, and also the ability to understand functions very well, because as I told you, internal auditors get into a certain function, within 2 to 3 weeks, they study the whole function. Obviously, they spin out an audit observation to the person who has been doing it for the past 5 years, saying that you are doing correct. It's an ideal asset.
Yeah.
So this was an ideal opportunity for us to springboard the internal auditors, get them into the business and show them that, see, you have a wealth of knowledge here, so why don't you use it? And also, this became a byproduct for the business as well. This machine learning models that we developed again gave us certain clusters which even categorize the user behavior, which then enabled the business to use it as a cross-selling opportunity as well. For example, if you take a certain household, because of the machine learning's trend identification, it exactly knows in a certain given household how many NICs are there and how many products they are using. And also there are certain user behaviors, even up to their user behaviors of, what they purchase on e-commerce, what kind of products they use in the vehicle, what kind of products they use, and so on. So this again, as a byproduct, created an opportunity for the business to get the output what we create from the machine learning model to then springboard it towards cross-selling as well to the business.
So that, which means in summary that the system that you built not only was limited to the risk identification,
Yes.
but also could support the business with some new opportunity.
Exactly. It created a whole new ecosystem with opportunities. Yeah.
New opportunity could be created.
So I think this ecosystem I think if explored well would have been a superb tool. Because anyway, technology is developing. So we developed this technology in 2018, 2019. Now I think IA&RM, we are working on a certain solution of trying to see whether we could incorporate blockchain into the normal transactions. I think first part was whether we were conceptualizing on smart contracts. So I think the potential is immense, because when you get blockchain, if you get smart transaction, for an example, the compliance check happens real time, then and there itself. Also with very clear audit trails coming into play. So I think the possibilities are endless in this whole equation. And I think things like coding is now could be done in a few seconds. Days to write a Python program. The entire scripting took us about 14 plus days, but now it's instant. Yeah. So I think with that,
sorry, just to disturb you a little bit, before you further go down, I'm really not because of the 45 past. So I think that's the part. So one thing that I'm not really clear is probably whether you can help me again.
Yeah.
How the machine learning was used to actually go beyond the traditional programming techniques.
Yes.
Was incapable of. Right?
Yeah.
Probably for you guys, to take it was clear, but for somebody who not.
Yes.
Right.
Yes.
It really emerged.
Yes.
Conversation.
Yeah. So what? Yes, that's question. Professional's question is very so it might be another case that we definitely the audience would love to listen to us. So if we think about a case like, yes, we know that ML is a machine learning can be applied to many things, and there are a lot of stories. It is going to be a trend. And in this particular use case, how can we look at that? It's not just something that we applied a typical algorithm, that we did something addition. And how could the customer can get this benefit from technological development to the business perspective. Just to understand from simple terms. We have some algorithms and we know that, certain machine learning algorithms, and we feed some data. So we train this and we use this. You explained that you tried out unsupervised learning. But for a listener who is listening to this conversation, definitely would love to get to know what additionally that we could do to bring this value. Can you please explain so what additional stuff that you could bring into this solution?
Yeah, so day in, day out, like I said, in the initial use case that I said, we built a rule-based engine.
Yeah.
So those were rules that we already knew.
The rule-based engine was on Python, if I'm not mistaken.
Python, and we had a visualization as well.
Okay.
Tableau. So
You had visualization.
we visualized the rules that were built
Yes.
on board.
Rules and features. Yeah.
So what the machine learning brings out, it unearths now day in, day out when in this case the fraud suspicious framework that we wanted to build in the ecosystem. We wanted to build in the internal audit ecosystem as well. So the rules will have, they will actually get for some sort of a maturity, and they will stay in that level.
Okay.
So beyond that, it won't progress.
Which means you have static rules. Yes.
Static
So
rules.
let's say if a particular person is going to do a fraud, so you have static rules.
Static.
If the person's behavior is changed, this particular static rule function will not be able to, will not be able to identify the different behavior.
So you use ML to
ML to
come up with a new rule.
unearth the other patterns. So
Right.
it's all about pattern statics.
Okay.
So
And
ML,
if I may ask you, like, you unearth some of the new patterns, and then you use those patterns to the game to
embed into the rule engine so that it will
become
keep
faster.
it focused.
Okay.
So the ML will give us more vision and more inputs on how we can improve our existing rule base.
Okay.
If we stayed in the same rule engine, it will go into a certain maturity level and it won't give us
Give results, yeah.
results beyond that. So because day in, day out, the technology changes, the mindset of a perpetrator or a fraudster will change on different avenues. They will try to work out. So we also, as auditors, we also need to be more vigilant, keep us to that level. So that's why we use ML. So it will give us more scope and breadth on how this can be used. So ML algorithms, that's why we use train different set of algorithms. They will give different set of results.
Yeah.
That results being trained and evaluated will be again retrospectively onboarded to this existing rule engine. So
Okay.
we can fine tune. It's a continuous.
Okay. It's a continuous process. So you have a process in place and then you identify, I would say, different behaviors of the customer or the end user who is going to do a fraud. So possibly it's a suspected case.
Yeah.
And based on identification, you again feed to the algorithms that it trains. It's a continuous process. That's what you are going to explain. Right. Good. I think Rukshan.
Yeah, I'm going to ask you a question now.
Yeah.
So now, given that now this obviously is a 10-year of a journey, right?
Yes.
So now the technology progress has been immense in the last couple of years.
Yes.
Which is where you guys kind of stopped on the project in. So if I were to ask you, like given the current trends on AI and then the technologies possibilities available now, how can that model be further in the current stack available?
Yes. So in today's trends, usually, I would say the algorithms are there.
Yeah.
And there are many algorithms that we use to look into. And the technology ground is always, it's like continuously growing.
Can it be like a sort of an agentic
Yes.
process where
Yes.
it self-learns
So,
and applies it back to
Yes.
yourself?
So yes, in enterprise solutions, that what we currently do is like we have this continuous learning. Yes.
Yeah.
So if you take an example like an organization, organization is a massive data set from different departments, different ends we collect the data. And there are, you exactly correct, options. Now, the way that we are looking into like agent model,
Yeah.
that this agent is going to take care of the data is being captured. And then ML is being applied and it's going to use the modern technologies to provide the predictive analysis And the exact piece of it is predictive analysis. So predictive analysis will bring us any alerts that's going to be a suspected behavior. And based on that, organization can go for decision making. And not only that, nowadays technologies are capable of providing you the decision. So human brain does not have to wait for decision making. And certain algorithms are capable of giving you the decision, you just have to choose. So
Even options of.
yes, you get the list of decisions that you can make. You just have to choose the decision, and then based on that, the algorithm is capable of providing possible results. So the overhead of a human brain has to be handled by many of the algorithms today, and ML is supporting towards that. So it's the current market that we have. So there are many tools and many algorithms and many AI engines are being released in today's market. So that's the current situation.
So I think, I mean, that's sort of that also to this conversation.
Yeah.
So, with the time constraints, I thank Arushan and Sarin for coming by and particularly live with your and like I thank operations for so thanks for joining for the panel and appreciate you guys joining. So we'll catch up later in a similar talk and help to spread the word of use of AI and ML in local context as well as in global scenarios. All right. Thanks, guys.
Thanks. Thank you. That's so much. Thanks.
Cool. A little bit.
Okay, so we can have some something.
That's better.
Because I know that
And the two of us record some quick timing kind of thing. Each might be a precursor to the recording itself, where we kind of give a summary.
Yes.
So that people will see that and they
Yes,
come to
yes,
so
yes.
see him at that. So that
Body
and you know the whole gist of it.
Yes,
You
yes,
can easily have a conversation about it
yes.
as something that you
Summary.
can show before the
Yes.
screen live.
Body preview. Body short calendar. Body cut.
So I will tell you and stay. So if there this focused looks like that. You guys can that's okay, that's true. Okay.
Oye, ya vale, bueno, están igual cogiendo que ya te.
This used to be easy, this whole thing was appearing here. Admin and control that. All the time උදාහරණයක් මයික් තියෙනවා. නඩෝ හයි කරලා කෝවිඩ් ගන්න හයි කරේ උරුද්දක් යූස් කරේ නැහැ. වැඩ කරන්නේ නැතුව. This in a sophisticated camera, but it can detect that you are sitting and talking. It goes automatically.
Okay.
Security.
Edit කරන්න පුළුවන්.
Like